Hi and welcome to this number fun training. I've entitled this session The Adventures of Titioning after one of my number fun characters. I'd like to share with you one of my passions, the use of story as a tool in the teaching of primary mathematics. There are three aims for this session. I want to explore how story characters might be used in the teaching of mathematics. I'd like to share my experiences in developing Titioning as a character to support the teaching of place value and calculation. And I want to hone in on the third one, to highlight some of the specific benefits of using story and context when developing conceptual understanding in formal methods of calculation. About 20 years ago, I was challenged to write some songs for primary mathematics. That's led on to a big project called Number Fun. The first song resource pack came out in 2003. We published it with full tracks and backing track CDs and ideas for teachers on how to use the songs effectively in the classroom. We produced over the years about 8 different packs. Well, there were 8 different packs. This is the 5th one in which Titioning, the character we're focusing on today, was first introduced. We now have the Number Fun portal. There are over 320 videos on there that feature the songs that are packed with story, visualization, animation and humour. I believe it's a teaching and reasoning tool that can help energise, contextualise, bring enjoyment and fun to the teaching of mathematics. So let's take a deeper look. In the Number Fun portal you'll find loads of characters. Here's Farmer Pete. He's one of the first Number Fun characters that I created. And here, in this scenario, Nibbles, his cat, is 8 metres up a tree. How is he going to rescue her? Well, the great thing is there's a new Number Fun character called Firefighter Esme. Here she is. Oh, Farmer Pete looks in a bit of a danger of getting wet. But she doesn't need her hose. What she does need is her super scaling ladder. She's got a 2-metre ladder. And the great thing is that if she multiplies that ladder by 4, makes it 4 times the length, she can rescue Nibbles from the top of the tree. I'm using this picture and this idea in this story context to help children understand the scaling structure of multiplication. 2 metres multiplied 4 times, or 4 times the size, is 8 metres. There's loads of Number Fun characters. Here's Farmer Pete and Nibbles and Farmer Summer, who's married to Farmer Pete. And they've got PC Plod and Sergeant Stephen. Those two look after odd and even numbers. And Sergeant Stephen's responsible for all things in Number Fun land, keeping control if you like. And she works with Number Bond 006-004, who's great at catching the sneaky criminals who've escaped from prison. Is my sort of James Bond type character. This is the super scaling Bluster, owned by the multiplication master on the left there with her sidekick Boffin. They also sort of explore the scaling structure of multiplication. They're particularly pitched at upper key stage 2. The guardian of the rule looks after algebraic sequences in upper key stage 2 as well. This is Farmer Pete and Farmer Summer's daughter, Alice, and she's also got another name. She's called MC Rapicoda Numbo, and she looks after all mental strategies, mental addition strategies particularly, so that's an acronym for those that are featured on the portal. And her cousin Tommy, well, he's a really active sort of character. He's used in loads of the songs as well. In fact, there are loads of children that feature across the portal. They're just a selection of some of the characters that you'll find. One of the first characters I created was Chip the Chopper, and Chip the Chopper just loves chopping numbers in half. So 12, chop, 6, and 50, chop, 25. That's part of one of the songs. But Titioning goes further. He's also a lumberjack. He just loves chopping logs up. And he came one night when I was thinking about this particular objective. To be able to partition 2-digit numbers in different combinations of 10s and 1s. I went to bed thinking, right, it'd be really good to have a song or a character or a thought that can help bring this particular objective to life. So in bed I was thinking partitioning, partitioning, but who could partitioning be, etc. And about 3 hours later, hadn't slept a wink, but I did have the idea for this first Number Fun song I'm going to show you. It's the song of Titioning, and Titioning organises his logs into loose logs and stacks of 10. So here is Titioning's song.
Chopping wood, I love to hear him say. So Monday I went down to see old Papa Titioning. Oh, when he laid his extra rest, he said the words that I like best. Child, would you move these logs with Papa Titioning?
There's 74 today. Child, if you take 17, I will carry 4. Child, if you take 16, I'll take 10 and 4. Child, if you take 50, I'll take 24. Child, if you take 40 logs, I'll take 34. Whoa!
I love this image. On the left I can see 4 stacks of 10, 4 tens, and on the right I can see 34 logs, 34 ones. I can also see on the left 4 tens, and on the right 3 tens and 4 ones. On the left I can see 40 ones, and on the right hand side I can see 34 ones. This is Titioning. And a few years ago I was teaching year 4 in a school. I joined the school to teach year 4. At the beginning of that year the children weren't confident with this sort of partitioning, so we used the song and they really liked it. They really enjoyed it, found it really helpful. But I made some mistakes. The mistake I made was this, that I just had this PowerPoint slide for that verse that you've just seen. I didn't give them any animated graphics, and I didn't give them any concrete resources to be able to use. Now, of course, Titioning's logs are based on our base 10 or Dean's equipment. And as I was thinking about the base 10 and Dean's equipment, I was thinking, well, how powerful that is. Can I develop the whole idea of Titioning's logs with base 10 equipment? Thinking, well, I've got thousands. What could that be? Oh, that could be a container. So we've got loose logs, which are the individual ones, tens, crates of 100, and containers of 1,000. Then I thought, well, can we extend that even further? And it seemed logical to do so. So 10 containers actually make a tower of 10,000 logs. 10 towers make a wall of 100,000. And 10 walls can make a compound, which is 1,000,000 logs. So that seems to work. Then I thought, well, what about going the other way? And if we have one log and split it into 10 equal parts, that will be a slice worth a tenth. And a chip can be 100th, and a splinter can be 1,000th. So this is Titioning's log classification system. And I've been using this little ditty with some of the children I've been working with recently.
There's 10 splinters in a chip, chips in a slice, slices in one log, logs in a stack, stacks in a crate, crates in one container, containers in a tower, towers in a wall, walls found in a compound, 1,000,000 logs, 1,000,000,000 splinters, logs abound in the compound.
So the song helps children grasp our base 10 system. It gives them a story and a context for understanding that 10 ones make a 10. 10 tens make 100, 10 hundreds make 1,000. And it helps them grasp place value right from thousandths through to millions. It's Titioning's log classification system. And as I've been exploring this with children, we've been playing in lots of different ways with this idea. I've created a whole set of playing cards, and we've used those for various games and activities. Here are some of the cards you can see on the screen. Here's the thousands, if you like. So thousands, tens of thousands, and hundreds of thousands. And these are the decimal representations. In fact, behind me here, I've got a version of that Cateno chart that I've used with the children. And I've got some magnets here on the board just representing 80,402.021 logs. It's actually proved to be really powerful and really helpful for the children I've been working with recently. So those cards and this particular version of a log Cateno chart are available on our Number Fun shop. So what's really going on? We're adding story and context to the teaching of mathematics and to place value there. Here's Rebecca and Henrietta. They both got eggs. Rebecca's got white eggs, Henrietta's got brown eggs. I wonder how many more eggs Rebecca's got than Henrietta. I wonder how many they've got all together. Well, this is a bit tricky to see clearly, isn't it? But if I arrange them, I can see really clearly that Rebecca's got 2 more eggs than Henrietta. In fact, if Henrietta moves that log into Rebecca's tens frame egg box, we can see clearly there are 16 eggs. I've been thinking about Farmer Pete recently. Here's Farmer Pete. His song is about, his original song is about sheep getting lost from the sheep pen into the tractor shed. The arrangement here is quite random. Now it's good for reasoning. I can see there are 7 sheep in the sheep pen because I can see 3 and a 4. But more recently I've exchanged that video for this video on the portal where the sheep are arranged in a tens frame format. So I can see that there are 7 sheep in the sheep pen. It's 5 and 2 more, 3 less than 10. I'm a big fan of using story and context in the teaching of mathematics. That's what mathematics is really about. It's about everyday life. So it gets a tick for me. But what gets 3 ticks is this: the use of context alongside arrangements. Tens frame arrangements or base 10 arrangements, as we've seen with partitioning. I think that's extremely powerful. And of course, for children to be able to tell stories and make up stories, they need to hear lots of stories. I think stories are a really powerful tool in learning. In fact, when I'm training teachers about mastery and calculation, I suggest to them there are 9 different jigsaw pieces that come together to help us really master calculation or help children master it. The first one of them is story and context. Now that might surprise you, but as I've been doing my doctoral research, I've been thinking and exploring the use of story in the teaching of mathematics. And if you go to Singapore, the mastery curriculum there, the use of story is embedded within it. In fact, the first thing children should be given an opportunity to do when they're exploring addition and subtraction in our year 2 and their primary 1 is to make up addition and subtraction stories using resources and connecting them to an equation. And this is consistent across the year groups. They're always creating stories. This is called problem posing. It's an aspect of problem solving. And it's connected to word problems. So children are encouraged to use and create story. It's actually a type of effective questioning, and this is a section from the Singapore primary curriculum where it talks about sort of assessment in the classroom and the power of using really good stories or really good questions, which I think tell me a story or what's the story behind this is a really powerful question. It can help teachers probe understanding, correct misconceptions, reinforce a point and expand an idea. But there's mega benefits for children as well. It helps children formulate their ideas, communicate and share ideas, and hear the ideas of others. They can articulate their thinking and in story creation deepen their understanding about the structures and the operations themselves. It can develop confidence. And they can talk about mathematics and use it. So there's loads of benefits for children in terms of developing and deepening their understanding, but also for teachers as well, who can then assess where their children are at and then move from there. So tell me a story is a powerful idea. And of course, we can only tell stories if we've heard loads of stories. So we have this idea of problem posing then. and it sits within the paradigm of problem solving, and it's this generation of new problems. But when you look at the literature about the use of story and learning, there's loads of benefits, not just in terms of the problem posing. We're hardwired to actually learn through the use of story. And story can make mathematics more enjoyable, memorable, engaging and understandable. It is a powerful tool for just establishing meaning. In fact, Egan, who was one of the first writers about the use of story, he says that children can readily understand abstract concepts when organised in story form, like an abstract procedure. So when we master calculation, story is very much at the heart of it. We want children to understand the structures, and we're going to teach those through story. We want them to know the technical vocabulary. We need them to develop number sense and to know the number facts. They're crucial for calculation. I know Titioning helps with the number sense there in terms of place value and his logs. We've got concrete resources and pictorial representations, and we've got mental strategies and written strategies. I think these are the 9 jigsaw pieces that come together, and story impacts a lot of them, if not all of them. Let me tell you about something that happened a few years ago. I was teaching year 5 class, and then in the mathematics sessions I was teaching the higher ability year 5 and year 6 group. And I hadn't taught them short division, but I was asking them and challenging them to demonstrate their understanding and their ability to fulfill the procedure. So here's an example of one of the calculations my children were working on. 465 divided by 5, and I challenged them to find the quotient. So the procedure says this: how many 5s in 4? Well, there aren't any. Remainder 4. So how many 5s in 46? 9, remainder 1. How many 5s in 15? 3. So the procedure definitely works. But I can remember that session I had with those children because one of the girls popped her hand up, and I went over and we started reasoning and discussing what she was doing. And she looked up at me and she said to me, "Mr. Godfrey, I haven't got a clue what I'm doing," which is really interesting. And I was thinking, well, why? And the issue was this, that young lady knew that 4 wasn't a 4. It was 400. She knew the place value. And how many 5s in 400? Well, there's actually 80. But she wasn't writing 80. So what was going on? So the procedure, how many 5s in 4, ignores the place value of the 4, but the procedure works. But if we acknowledge the place value and say, well, that's actually 400, how many 5s in 400? 80. Well, the procedure doesn't work. And then we've got this idea, or we could reason, well, what it really means is how many 500s are there in 400? There are none, remainder 400. But that ignores the place value of the divisor. We're not divided by 500, we're divided by 5. Now I can remember that particular lesson because I was thinking, right, I really need to help her understand what's going on. Maybe I should get some base 10 equipment out and show her that. But I remember being completely flummoxed. How on earth can I teach that with real understanding? It just doesn't seem to make sense. So let's go on a journey of thinking. When I'm doing some division training with teachers or when I'm working with children and teaching them, I'll often do some problem posing. So make up a division story problem about 15 divided by 3. And I'll encourage people to use counters or cubes, something to represent the context of their story. Usually people end up with this sort of image in front of them, and occasionally some people end up with that image. In fact, sometimes I use this slide and say to people, well, which of these images do you think represents 15 divided by 3? The majority of us tend to think, from my experience, of the left-hand side, the left-hand picture showing us 15 divided by 3, because we tend to think sharing by default. So 15 sweets shared between 3 children. How many sweets does each person get, or each child get? They get 5 sweets. The other side, of course, is the other picture of division. It's the grouping structure. So you might have, say, a class of 15 children, which is a lovely small class, and you might challenge the children to get into groups of 3. So how many groups of 3 can we create? Well, 5. So we've got these two structures behind division. We've got sharing and grouping. Here is a number fun little snippet. Oh, actually, before I show you the number fun snippet, here's what got me really thinking about the use of story in the teaching mathematics. And this was from the NCETM primary assessment materials in 2015. And the materials suggest that children should be able to make up more sharing stories like the one above. The materials also encourage children to make up 2 more grouping stories like the one above. It's the only example of problem posing in all the documentation, but it does mirror what's going on in Singapore. So that got me thinking. So here is a snippet from one of the Number Fun songs. And I'd like you to watch carefully the animation and the pictures that are created.
12 girls shared equally, division by sharing. 12 girls in groups of 3, division by grouping.
Okay, so we've got the sharing image on the left hand side, which we know is partitive division. So the 12 girls have been split and shared between 3 equal groups. It's one for you, 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 etc. So the quotient is how many are there in each group or each set. The grouping picture says how many 3s are there in 12. So how many groups of 3 children have I got? Well, I've definitely got 4 groups. And we need clarity on that. Sharing, partitive division, or grouping, quotative division. I want children to understand the vocabulary and know the vocabulary. So I've got my dividend divided by my divisor that equals my quotient. I can remember this day really clearly too. This was when I was on the NCETM Professional Development Lead training program led by Pete Griffin and another presenter. Pete on this session helped us understand how to teach short division with understanding. So he had this scenario. In fact, this is his slide. 138 divided by 6. And we used place value counters for the first time. It was my first experience of using place value counters. 100, 3 10s and 8 1s. And Pete suggested to us that the key to understanding short division is using the sharing structure. So I've got 100 to share into 6 equal groups. Can I do that? Well, no. I'm going to have to exchange that 100 into 10 10s. 13 10s and 8 1s is how I'm now thinking about my 138. And now, of course, I have got the ability to share the 10s. So that's 1 10 each. In fact, there's 2 10s each, but I have 1 10 left over. So each group has 2 10s in. There's 1 10 left over. So I'm going to exchange that into 10 1s. So I'm going to end up with 18 1s. Now the 18 1s can be shared fairly between these 6 different groups. So there's 1 each, there's 2 each, and there's 3 each. And I really like the way Pete encouraged us to arrange the counters in an array like this. 138 is represented, divided by 6 equals 23. I can see 23 multiplied by 6 is 138 really clearly. Now in Pete's presenter's notes, which went alongside this PowerPoint, he made these thoughts. He noted these things down. That we can explicitly see in this image the sharing model. We can see 23 6 times. A sixth of 138 is 23. He also suggested that we can't see the grouping structure because the grouping structure says how many 6s in 138. Well, we can't see 23 6s. We can't see the grouping structure. So sharing is important for helping children understand short division. It's the sharing structure. But as I reflected on that day, I thought, well, what about partitioning? The use of story and context to support this way of understanding short division. So that led to the creation of this story, Partitioning's division song.
Peppa T, there's a lot of logs in your house again.
Sure is, darling. They're for my division song. I got crates of 100, I got big stacks of 10. I got loose logs lying on the floor. My house is full of bursting, I I've got all that I can fit in. 834.
Peppa T, 6 care homes need your logs.
Okay, darling. I got 800 crates to share by 6. That's 1 crate each, 2 left over. 2 left over. I'll cut those crates into 20 stacks of 10. 23 stacks. 23 stacks. Buy my sofa. I love my sofa. It's a lovely sofa. 23 stacks of 10 to share by 6. 3 stacks each, 5 left over. 5 left over. I'll split those stacks into 50 loose logs. 54 logs. 54 logs on my sofa. 54 loose logs to share by 6. That's 9 logs each, none left over. None left over. It's time for rest and a cup of tea. At last I can sit down on my sofa. 139 logs for each care home, darling.
Let's take a look at one final example. 612 is our dividend, 4 is our divisor. So what's the quotient? Well, we have this abstract procedure. We can say how many 4s in 6, 1 remainder 2. That's what the procedure encourages us to think, but we ignore the place value, don't we? Because we know that 6 is worth 600, so 600 divided by 4 is 150, but the procedure then doesn't work. And if we ask how many 400s in 600, well, we're ignoring the place value of the divisor. But if we suggest there's 600s to share between 4, that would be 100 each, 200s remaining. Well, that makes sense. The sharing model definitely makes sense. And it's the same as we proceed through the procedure. So we've got 21 tens. 21 divided by 4 is ignoring the fact that it's actually 210. 210 divided by 4, well, the procedure doesn't work because we get the solution there is 52 remainder 2, so that doesn't work. If we say how many 40s in 210, well, got the same issue there that 40 isn't our divisor. It's only this sharing picture that 21 tens divided by 4 equals our 5 tens with 1 10 remainder. So sharing works. So we've got this clarity now that sharing is the picture we want to help us understand what is otherwise an abstract procedure. So let's go to the NCETM Ready to Progress criterion PowerPoint version that was introduced in 2020. Now I like a lot of these, but I wonder whether this PowerPoint has got the clarity we need it to have. Now whenever I start a calculation like this, I'm now beginning to think story. I'm thinking partitioning's logs, but there's no story context here. So, but maybe in the back of our minds, we might think about that as we go through. So this is their PowerPoint. First of all, we need to write the dividend and the divisor and the dividend. I like that. I like the fact we've got place value counters. Let's see what happens. Step 2, sharing the hundreds. Okay, so if I'm sharing, I'm looking for 4 equal groups is what I'm looking for. So the place value counters have been organized like that. Does look a bit like one group of 400s actually, but let's progress. So we've got 1 remainder 2 in terms of the hundreds. So we're going to end up exchanging the hundreds into tens. So we've got 200s going to give us 20 tens. Therefore I can see 21 tens. That makes sense. Now I need to share the tens. So I'm looking to share those tens into 4 equal groups. Let's see what the imagery does. Well, that looks like one group, another group, another group, another group, and it looks like I'm seeing 5 groups of 4 tens. Whereas actually I want to see 4 groups of 5 tens, don't I, for the sharing model? So I'm wondering whether I'm actually seeing a sharing vocabulary being used whilst visualizing a grouping structure. I can see sets of 4 tens there. Interesting. Okay, so let's progress. So we've got 5 groups of 4 tens there rather than 4 groups with 5 tens in. And the last bit we're going to exchange. We'll exchange a 10 ones. So we've got 12 ones. So now we're seeing in step 6 the sharing of the ones. So I'm expecting to see 12 ones shared into 4 equal groups. It looks like I'm actually seeing the 12 ones shared into 3 equal groups of 4. So again, am I seeing more of a grouping picture? How many 4s are there in 12? Well, that is what I'm seeing. I'm not seeing the 12 shared into 4 equal groups of 3. We get to the divisor of 153. So let's ask Pete's questions. Can we see grouping for 153 times in the place value counters? Well, I can definitely see 400s, and I can see 5 groups of 4 tens. I can definitely see 3 groups of 4 ones in the ones. Can we see sharing? 153 4 times. 4 rows of 153. Can we see that a quarter of 612 is 153? Well, not at the moment. So this is my animation. I probably wouldn't have the bounding boxes like that. I'd have them like that. Because I can now see definitely 153 shared into 4 equal amounts. But does it have the story? Does it have the context? And maybe it needs the story and the context to help bring real clarity. So let's go to Papa Titioning's version. So if he has 612 logs, he's going to organise them into crates of 100, big stacks, 10 and loose logs. He's got to share them between 4 care homes. So here we go. 600 crates to share by 4. Well, that's definitely 1 crate each. 2 left over. And those 2 crates of 100, I think this is worth noting, are actually regrouped. They're not exchanged, they're just regrouped, which is what mathematically we're doing. When you have concrete resources like place value counters or base 10 equipment, you have to do a physical exchange. But mathematically, we're regrouping. So those 200s are being regrouped into 20 tens. I now have 21 tens. I'm then going to share those into 4 equal amounts. So each care home definitely gets 5 tens worth 50. And that 110 is going to be regrouped into 10 ones. So we now have 12 ones, and those 12 ones or 12 loose logs can be shared equally between the 4 care homes. So each care home gets 3 logs. It's time for rest and a cup of tea. At last I can sit down on my sofa. There seems to be clarity in the picture. It's definitely a sharing structure. And if I organise the image like that, I can see, like Pete had originally, 612 shared into 4 equal parts, 4 care homes, 153 logs each. Here's how I might tackle this calculation using place value counters and Papa Titioning's story. I've got 612 logs to share between 4 old people's homes. Oh, I love it. Why, let's work with the crates of 100 first. Well, that's 1 for you, 1 for you, 1 for you, and 1 for you. Oh, I've only got 2 left. Can't share those yet. So everyone gets 1 crate of 100. And these 2 crates of 100 I need to exchange into big stacks of 10. So let's do that exchange. Here's my crates. I'll just spread them out so you can see them. There's 5. There's another 5. That's 11 so far, plus another 10. 21 stacks of 10. I love it. So let me record what I see. I can see 21 stacks of 10. Now I'm going to share them between 4 old people's homes. I'm just going to put them in my hand to make it easy. I love it. 1 for you, 1 for you, 1 for you, and 1 for you. That's 1 each. There's 2 each. There's 3 each. There's 4 each. And, I've got enough for 5 each, I think. With 5 each, I've got one. I can't share this stack of 10 yet. So, everyone gets, all the care homes get 5 stacks of 10 each. I love it. Let's just exchange this 10 for 10 ones. 10 loose logs. Here we go. There's 5. There's 10 plus 2 more. I got 12 loose logs. Right, I'm going to share those between my 4 care homes. Well, there's one for you, one for you, one for you, one for you. That's 1 each. And there's 2 each. And there's 3 each. I love it. 3 loose logs each. So each care home, you're going to get 1 crate of 100, 5 stacks of 10, and 3 loose logs. Here's another way of tackling 612 divided by 4. Now this is more of a grouping structure. It's a partitioning one. So we partition 612 into 400, which we know is a big multiple of 4. It's 100 times 4. And 212. And then I'm thinking, well, I've got a multiple of 400s. Now I'm looking for a multiple of 410s. 200 will be a good partition there, because that's 40 multiplied 5 times. So I could partition 612 into 400, 200 and 12, and then divide those chunks by 4. 400, how many 4s in 400? 100 of them. How many 4s in 200? 50 of them. How many 4s in 12? 3 of them. So again, I end up with my quotient as 153. This is a grouping picture, or a strategy that's based on the grouping picture. So I want children to master division procedures and strategies. And to do so, I think they need to be able to articulate and talk about the structures behind each strategy, to be able to tell you a story about what's going on, to be able to name each part of the equation, and to remember the facts that they need. I want them to be able to talk clearly and confidently about the place value of each digit, to explain what they're doing, to be able to reason with you how they know the answer is accurate, to be able to spot the inverse. I want them to be able to use concrete resources and pictorial representations to demonstrate their understanding. And I want them to be able to find the quotient using a different strategy. I think that is mastery of division. So, let's bring it all together then. I'm really interested in children grasping conceptual understanding in mathematics. Wong here in 1999 proposes a 6-fold multimodal hexagonal framework. You see I've highlighted there story. He's passionate like me in the fact that children grasp understanding when it's put into a context. In fact, whenever I'm teaching, I have this sort of like image in my head. It's of a tree, and trees obviously have roots, and I want children to have really deep learning. And I think deep learning is built through the use of the concrete, pictorial and abstract approach. And I want children to be able to reason confidently across those representations. But I think at the heart of it, on the trunk if you like, is this idea of story. So story is right at the heart of teaching for mastery and calculation. We've looked at the use of story and context alongside arrangements and just how powerful that is. We haven't looked at vocabulary particularly, or the use of story to teach vocabulary. I would definitely use a story like Rebecca and Henrietta's story of how many more eggs has Henrietta got than Rebecca. Well, that's an idea of difference, isn't it? That's what the answer is, or the solution is, in a subtraction calculation. I could use that there. We haven't used story in the teaching of number facts in this presentation, but I definitely use story to help children earth and understand number facts and mental strategies. You'll find loads of examples of those on the Number Fun portal. But what we have done is use the use of story to help children develop number sense. That's where Partitioning's log classification system comes in. We've used story to help children grasp sharing and grouping as structures of division. We've used story to help children gain deep understanding of the short division procedure. And we use story in connection with the pictorial representations of partitioning's logs. And then the use of place value counters or base 10 equipment. If you'd like to see a summary of the training that I've done here in a printout form, this is a free download from our Number Fun shop. It's The Adventures of Partitioning, loads of links on it, an interactive PDF document that can take you on a journey of thinking there. I've referenced various resources there, so if you're interested in that, please do check those out. And thank you very much for joining me on this training. I hope it's been helpful and inspiring. I encourage you to go on and use story and context as a tool for learning in the teaching of mathematics. Please do check out the Number Fun portal. On there you'll find partitioning is being used now to teach the formal strategies in addition, subtraction, multiplication and division. In fact, I've got 3 videos for each of those operations that are graded differently. So an easier version, a middle version and a harder version. So please do check those out, and I hope you find them as powerful tools to help you to teach calculation really well and with use of story at the heart of it.